Let us prove by mathematical induction that n into n plus 1 into n plus 2 is divisible by 6. Let Pn be the statement. When we say n into n plus 1 into n plus 2 is divisible by 6, we assume n equal to 1, 2, 3, 4 and so on. 1, 2, 3, 4 and so on. Therefore, P1 is the statement one into 1 plus 1 into 1 plus 2 which is equal to 6 is divisible by 6. Is this true? Is 6 divisible by 6? Yes, of course, 6 is divisible by 6. Therefore, P1 is true. So, the statement is true for the starting point. Let us assume Pn is true for some let us assume Pn is true for some fixed n equal to k. Now, if we want to prove something, then you have to assume something. So, we assume that Pn is true for some fixed n equal to k. Then, now we assume that it is true for n equal to k. We show that it is true for n equal to k plus 1. K plus 1, instead of n we write k plus 1 here. Instead of n we write k plus 1. Instead of n, k plus 1. That is equal to k plus 1 into k plus 2 into k plus 3. We are replacing n by k plus 1. So, you get this. By our induction assumption, k into k plus 1 into k plus 2 is divisible by 6. So, let us break it. K into k plus 1 into k plus 2 plus 3 into k plus 1 into k plus 2. So, we break this expression k plus 3 into k plus 3. By our assumption, as I said earlier, if we want to prove something, we have to assume something. By our assumption, k into k plus 1 into k plus 2 is a multiple of 6. Further, k plus 1 into, so this quantity is a multiple of 6. Further, k plus 1 into k plus 2 must be even. Therefore, 3 into k plus 1 into k plus 2 is again a multiple of 6. So, this quantity is a multiple of 6 by our assumption. This quantity is a multiple of 6 because 3 is a multiple of 3 and this is a multiple of 2. Now sum of multiple of 6 is again a multiple of 6. Last point. Sum of multiple of 6 is again a multiple of 6. Sum of multiple of 6 is again a multiple of 6. Once again, this is a multiple of 6 by our assumption, by our induction assumption. This is a multiple of 6 because this quantity is even, k plus 1 into k plus 2 is even, and 3 is multiple of 3. Therefore, k plus 1 into k plus 2 into k plus 3, since sum of multiple of 6 is again a multiple of 6, is a multiple of 6, in other words, is divisible by 6. And that is the expression that for pk plus 1. Therefore, pk plus 1 is true whenever pk is true. Now, when we take k equal to 1, we observe that p2 is true. Now, again when we take k equal to 2, we observe that p3 is true. Again when we take k equal to 3, we observe that p4 is true. Again if we take k equal to 4, we observe that p5 is true. Therefore, Pn is true for every n. In other words, n into n plus 1 into n plus 2 is a multiple of 6. N into n plus 1 into n plus 2 is a multiple of 6.